In the last video, we revisited the concept of a rational expression, and we basically learned that meant something with we pretty much think of it as something with a fraction in it. Talking about fractions, and last time we graphed them. In this video, we're going to discuss how you simplify rational expressions. You make them a little cleaner and kind of combine things, so it's less of a pain to look at. So if we look at this first example here, this is a problem you should already know how to do because we talked about it earlier on in our properties of exponents chapter. We have 4 x's up top, we have 7 x's on the bottom. After the x's cancel, there are going to be 3 x's left over, and they're going to be on the bottom. So I have an x to the third down here. If I look at my numbers here, I have 6 over 8. I can reduce that, and it will reduce to 3 over 4. So my final simplified answer for this first problem here is 3 over 4x to the third power. Now, in the instructions here, I say to simplify, but I also say to state any excluded values for x. When you have problems where x is in the bottom of your fraction, like right here and right here, we have to be careful because we cannot divide by 0. If my denominator was a 0 right here, that would be really bad because that's not defined. We couldn't actually have that as an answer. So what I need to do when I get my answer is look at my denominator, the original and the final one, and see what numbers I would have to plug in here for x to actually get out a 0 for the bottom. So in this particular problem, the only number I could plug in right there to actually get out 0 altogether would be 0, because 0 to the 7th is still 0, times 8 gets you 0. So if x was 0, that'd be really bad, because then we would divide by 0, it wouldn't make sense. So what I do right here is I say x can't equal 0. So you kind of say, hey, x can be whatever you want, but it can't be 0, because then we would divide by 0. On our next problem here, a lot of kids' first instinct is to cross out these x's and just kind of go from there and get a number answer. When you see pluses and minus signs in between terms, you're not allowed to just slash out like that. That's not an option. So what we have to do here instead is try to factor it somehow so we don't have those pluses in between our pieces. So looking at this guy right here, there's a GCF of 4 that goes into both of these. When I take that out, I have x minus 3 left over. So if I distribute this back in here, just pulling out a GCF, we get back to 4x minus 12. And on the bottom, I can take a negative 6 out of both parentheses, making it negative because that's what my variable is. And I will end up with x minus 3 right over there. And as luck would have it, when I do that, my parentheses here match. So I'm allowed to cross out those x minus 3's, getting just 4 over negative 6 for my answer. I'm allowed to do that because now I didn't break any plus or minus signs like here. It's really just a time sign right there, and that's totally fine. These slash out. 4 over negative 6 reduces to negative 2/3. So that's going to be my answer. In terms of our excluded values for this one, we got to figure out what number you would plug in for x to actually get out a 0 in the denominator. And the key to that, it's a lot easier to see when it's factored like this. In order to make this parenthesis a 0 right here, x would have to be positive 3. If x was positive 3, we would get 3 minus 3 is 0, times negative 6 is still 0. So what I'm going to do here is say x can't equal 3 so that I know we're not going to end up dividing by 0. On our final problem in the video here, sometimes you'll have things quadratics, you can have higher degree polynomials as well. But again, you can't just cross out the x squareds here because of these pluses and minus signs. Pluses and minus signs make things a little trickier. So what we need to do here is actually our magic numbers, thinking back to earlier on first in the semester. We need 2 numbers that add to 7 and multiply to 1 times 10 is 10. And as it turns out, my magic numbers are going to be 5 and 2. And since it's just regular x squared, don't forget you can use the shortcut. I'm going to turn my top into just x plus 5 times x plus 2. Oops. On my bottom here, I need 2 numbers that add to negative 6 and multiply to negative 16. And after thinking about that for a little while, you come up with negative 8 and positive 2. So this is going to turn into x minus 8 and x plus 2. As luck would have it, these 2 parentheses here are the same. They're allowed to cancel out, and there's nothing you can do with these 2 right here. So my final answer for this one is just going to be x plus 5 over x minus 8. And I also need to give my excluded values here, the values I can't use. In my final problem, it'd be really bad if x was 8, because that would make your bottom 0. So I need to write down x can't equal 8. But I also need to take care of this parenthesis right here. Even though that part canceled out, A negative 2 would have been really bad because then I would end up dividing by 0 if I multiplied this together. So I'm also going to say x can't equal negative 2. So as kind of a final comment for yourself on these problems here, when they're talking about excluded values, what values will make my denominator 0? And those are the values that you need to make sure you exclude.